Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kimi bin Muhammad Syukur, 23DM 21F1011. Today I would like to present about eoc1. So for the DC converter that I use is a single phase full bridge rectifier. So what is single phase full bridge rectifier? Single phase fully controlled bridge rectifier are no more commonly as AC to DC converter. Fully controlled bridge converter are widely used in a speed control to DC machine and easily obtained by replacing all 4 diodes of bridge rectifier with transistor. Next, the working principle for single phase full bridge rectifier. So during the positive half cycle of the AC input voltage, the upper 2 diode D1 and D2 conduct and the lower 2 diode D3 and D4 are reverse bias. As a result, the current flow through the load in the one direction, producing a positive half cycle of the output voltage. Next is during the negative half cycle of the AC input voltage, the lower 2 diode D3 and D4 conduct and the upper 2 diode D1 and D2 are reverse bias. As a result, the current flow through the load is opposite direction, producing a negative half cycle of the output voltage. Next, the function of single phase full bridge rectifier is to convert an AC voltage into a pulsating DC voltage. The rectifier output voltage is used to power electric device or charge a battery. So here are some of the function of a single phase full bridge rectifier. So the first one is power supplies. The rectified DC output voltage from a full bridge rectifier is used to power electronic device such as TV, computer and other electronic device. Power supply used in a such device usually include a full bridge rectifier followed by a filter capacitor to produce a smooth DC voltage. Next is motor device. Full bridge rectifier are also used in a motor device to convert AC voltage to DC voltage for powering the motor. The rectified voltage is then fed to an inverter that converts it into a variance frequency AC voltage that travel the motor. Next one is the battery charger. A full bridge rectifier are used in battery charge to rectify the AC voltage from the main supply and produce a DC voltage for charging a battery. A full bridge rectifier can handle highest power level and is more efficient than a half bridge rectifier. Lastly is welding machine. Next, we go to a circuit diagram. The circuit consists of transformer with a center tap, secondary winding, 4 diode D1, D2, D3 and D4 and a load resistor RL. The AC voltage is applied to the primary winding of the transformer and the second winding is center tap and connect to the diode and the load resistor. Next, we go to the waveform for single phase full bridge rectifier. So during the positive half cycle of the AC voltage, the voltage at a point A of the transformer secondary is positive. The voltage at a point B is negative. Diode D1 and D2 are forward biased and allow current to flow through the load resistor in the direction from the point A to the point B. Next, during the negative half cycle of the AC voltage, the voltage at the point A of the transformer transformer secondary is negative and the voltage at the point B is positive. Diode D3 and D4 are forward biased and allow current to flow through the load resistor in the direction from point B to point A. Next, we go to the AC voltage that I choose is a single phase to single phase cycloconverter. So what is cycloconverter? The standard definition for cycloconverter from Wikipedia goes as follow: a cycloconverter CCW or a cycloconverter convert a constant voltage, constant frequency AC waveform to AC waveform of a lower frequency by synthesizing the output waveform from segment of the AC supply without an immediate DC link. Next, we will go to the single phase to single phase cycloconverter working principle. So a single phase to single phase cycloconverter is an electronic circuit that converts the frequency of the input AC power to a lower or highest frequency output AC power. It can also change the output voltage amplitude and the phase angle. The input AC voltage is applied to the primary winding of a transformer. The transformer secondary winding is cycle tapped and connect to two pair of transistor SCR as shown in the circuit diagram. The transistors are connected in anti-parallel pair T1, T2 and T3, T4. During the positive half cycle of the input AC voltage, the transistor T1 and T2 are forward biased and conduct, while the transistor T4 and T3 are reverse biased and do not conduct. The current flow from the cycle tap of the transformer secondary through transistor T1 and T2 and then to the load. After that, we will go to the single phase to single phase cycloconverter function. A single phase to single phase cycloconverter has several functions and applications. So the first one is frequency conversion. A cycloconverter can convert the frequency of an AC power supply to a lower or highest frequency. The second one is voltage control. The output voltage of an cycloconverter can be controlled by adjusting the fire angle of the transistor. This allows the output voltage to be adjusted to match the requirement of the load. Next, phase control. The phase angle of the output voltage can also be controlled by varying the timing of the transistor firing. This function is useful in application where previous control of the phase angle is required. Next, power factor correction. Next one is motor control. Lastly is the power generation. Cycloconverter can be used in renewable energy system such as wind and solar power to convert the variable frequency output of the generator to fixed frequency suitable for use in the power grid. Next, we will go to the circuit diagram and the waveform for single phase to single phase cycloconverter. So that is the circuit diagram for single phase to single phase cycloconverter. And for the waveform of a single phase to single phase cycloconverter depends on specific configuration and control strategy used. I think that's all from me for presentation about eoc1 that I choose for DC converter and AC converter.